So now we're going to talk about the interface. We've defined the interface, right? The push, the pop, the peek, all that stuff. But in code, we want to separate the interface from the implementation. The idea being we can define the interface, we can define those without getting into the nitty-gritty of the behavior. We don't want to talk about how data is stored behind the scenes yet. We just want to run with it and just practice with the interface. That way we can separate the two. So the nice thing is it's also going to drive home the purpose of an abstract object or an abstract method. So let's define something called a stack interface before working on our actual implementations. And I'm going to open stack interface. I've got a file that's called stack interface. And we're going to code this one live. This is going to be one of the few things we code live. Okay. But we're going to say from ABC, we're going to import abstract method and ABC. We're just going to start here and we're going to define a class called stack interface. Okay. And I told you that it was going to be the benefit of an abstract base class. So let's just get that out of the way. Okay. The very first thing we're going to do is we need to define our initializer, right? That's the first method that we define in any class. And we know that we're going to need self. But let's think about this. When we called stack in that example code, we called s equals stack, right? We didn't provide it any parameters and just created a default stack, which is pretty common. We could call list, right? Or we could call set, and that'll work. And yeah, maybe we could define ways to initialize them, but let's just not. Let's just make an empty stack. How do we go about making an empty stack? Well, we don't know yet, do we? We talked about, hey, you know, this is how it behaves, but we're staying away from implementation details. So let's just not. Let's define this as abstract. Let me just do that way. If I spelled it wrong, I spell it wrong everywhere. Okay. And now what this means is, yeah, it's spelled right. Now what this means is any class that implements this, that extends the stack interface, is going to need to implement a constructor and explicitly define things. If they don't, it's not going to work. And the nice thing is we can just kind of do this, right? Okay, cool. Well, push. Are we going to need another parameter? Yeah, we're going to need our new element, right? The thing that we're pushing onto the stack. That's a big deal. But then what do we do with it? We don't know. We'll worry about that later. Pop, same thing. Peek, same thing. What about this? Notice that we're not calling something like s.len. We're calling len like we do for an array. Well, is there a way to do this programmatically in Python? Yeah. If we say this, dunder len, that's a magic method that says when someone calls the len method, when someone calls the len function and puts an object in, I should look in this method to provide the details on how len works. Pretty cool. Let's roll with that. And then is empty. Well, oddly enough, we can actually implement this one, right? How can we implement this? Well, we know what it means to be empty. It's empty if it doesn't have anything in it, if it has no data in it. Do we have a method that'll tell us if we have how many elements we have in our stack? Yeah, we have this. We have len. Okay, so we call that by calling len, right, function, but what goes in there? An object goes in there, but what object? Well, when we call this, right, S, whatever object you call it on, that's what gets mapped to self. So self is whatever object you called this on. So we can just get the length of itself, and that'll get the length. And so if that's equal to 0, it's empty. So we can just return, hey, if it's equal to 0, that'll return true, so it's empty, so we can return that. And if not, it's false. Now, why does this work? So you'll see the next thing that we're going to do, right? We've got our stack interface, and we're going to define 3 kinds of objects. We're going to define an array stack, a list stack, and a linked stack, right? So let's suppose we have this. Let's just suppose we say AS equals array stack, right? And then we immediately call AS dot is empty. So how does this work? Well, remember, duck typing is going to take a look at this, the thing that we called it on, and it's going to figure out what type it is. Well, it's an array stack, and it's going to go into array stack and look for a definition of is empty. Well, array stack is a stack interface object, and we have a definition here. So that means that our array stack's probably not going to contain it. So it's going to look here, it's not going to find it, it's going to go up the chain, it's going to look here, and it's going to find this definition. And it's going to run that. So it calls that, it defines self. Self is this AS now, and it's going to go return len self. Well, I got to find the len method for self. So it's going to go back through and it's going to do the same thing. Hey, AS, right? It's an array stack. Let's check that for a len method. Does that have a len method? Yeah, it has to, because we defined it here and we said it's abstract, which means that any class that inherits from this class must implement this method. If it doesn't, it won't work. Therefore, this class has to have the len method. And so that's the functionality that gets provided here. Neat. And if I open the stack interface that is implemented, this is actually up on our Canvas page, should be both in the module as well as in the lab. You'll see this exact thing. The difference here is these comments. But you notice everything else the same. So now that we have that, right, we now understand how a stack works generically, right? What the behavior is. We understand the general interface. We have defined a code interface that will force us to behave. So now the question is, what's going to be our backing data structure? How are we going to implement this? How are we going to store our data? And we're going to have 3 options. We can use an array, a dynamic array, or a linked list. So we'll go through all 3 of these options one by one.